If you guys remember, our course is not the name of the course. Yes, it's Survey 3 to 5, and the name of the course is Surveys and GIS. And so far, what did we cover in our class? I want to show you the big picture of our course. So really, we started from surveying, from first year kind of review. What is my total station? How does it work? What are the applications? What are the components, etc., etc., etc. And then this ties into so many calculations in terms of either coordinates or maybe volumes and profiles. So we spent some time on estimating the volume and using the surveying data from total station to make a meaningful product, like for example, maps, topographic maps, cross sections, volume, etc., etc., etc. So this will basically the first half of the course. Then in a matter of 2 weeks and a half, so we are able to cover photogrammetry. And I'm hoping that some of you, appreciate, understand the importance of photogrammetry and as an amazing tool that can create for us a very, very dense 3D model for our area using very accessible, tool like cameras. And then from photogrammetry, we are able to look at different techniques called LiDAR or laser scanner. So last class, we had 2 hour session on laser scanner and LiDAR system. And I need to remind you, those are not the same. Huh? Laser scanner is not a LiDAR system. Okay. So we had chance to spend some time on laser scanner and LiDAR system and understand the system component and how they work and what kind of product we get. And remember, for every technique, which is very important, very, very important, for every technique, it has its own limitation. It has its good and bad. And that's why there is never a single surveying technique that will ever vanish. Okay. For example, some of you will say, okay, why do I need total station in 2021? Why still people are buying total station? Why are still some people are using GPS? Every surveying technique has its own power, its own weakness. Some of them they fit very well into one application, and some of them they don't. And I think we mentioned this several times. For example, we talked about mine survey. For mine survey, can I do and use photogrammetry? Obviously, you cannot. There is not enough light. And can I use a total station? Probably you can. But if you want to use it inside the mine, you need to use a reflectorless mode because there's no way of you placing a prism on the tunnel sides. It's very inaccessible. Can we use laser scanner? Yes, we can. And so on and so forth. Okay, so this discussion can take a very long time, really on a very high level. What I want to say is that we have so many surveying techniques and all of them, they are valuable. They vary in accuracy, they vary in productivity and so on. And for one specific technique, based on what you learned in my class, by now you should be able to say, you know what, this application, I would go for this technique, but not this technique because of this, and this. Okay? But you know what? Here is what we covered so far. We covered several surveying technique, and the goal of all the techniques is the same, no change. My goal in every surveying technique is to locate a point in space, to tell this point the coordinates are here is the XYZ. Total station, we find XYZ. Photogrammetry, we find XYZ. Laser scanner, we find XYZ. GPS, we find XYZ using different ideas and methods. So this assembly is your first part of the course, surveys. Now the course is surveys plus GIS. Okay, now we're getting into GIS part. And you know what? As we go in GIS, some of you will think, oh my God, what this has to do with surveying? Why the SAIT decided or other institute decided to include the GIS part in the surveying course? What is the relationship? You will see this very shortly. Huh? Some of you, I bet you will get this question in your mind. Why is Tahir or Said or any institution would teach GIS as part of a surveying course? Because you will see at some point you will feel, no, this is not really a surveying. Okay. However, few couple of things I want to mention, two things I want to mention at this point of time. Number one is GIS, it is not a surveying technique. So which means GIS is not like GPS, GIS is not total station, GIS is not LiDAR or photogrammetry, which means in GIS, it's not really a equipment or a technique that I'm able to find my XYZ. So that's one fact. So GIS is not a surveying technique. Number two, why are we teaching GIS in a surveying course? Because there is a very, very, very strong relationship between GIS and surveying, and you will kind of get an idea what this relationship in today's class. Okay, are we ready to start? Yes, we're ready to start. Let's go ahead and look at the definition of GIS. So, you know what? There are some definitions, and probably when I read for you the definition, maybe you will get some idea, but it is not everything. So, really, a GIS definition, and sorry, I forgot to tell you what GIS stands for. And I am kind of feeling that probably you guys are able to tell me what does GIS stand for. Like GBS stands for Global Positioning System. GNSS is called Global Navigation Satellite System. So if I ask you, what do you think about what the word GIS stands for?
Geographical Information System.
Yes, sir. Thank you so much. Very easy. I think most of the people out there, they kind of are familiar with the word GIS stands for Geographic Information System. And why I stress this one? Because you will see every part or every word in the name, it has a meaning. Remember this, huh? Geographic, geographic. Number two is information. Number three, it's a system. And as I said, every word of the three words has a meaning. So let's get started here about the definition. So it's a computer hardware, software, and individuals like human to input, analyze, and display of a special related attribute information. There are two words on my slide here. You will get more information about it shortly. Huh? So we talk here about a couple of words, very important. The word spatial, okay, and also attributes. Those are very, very important names in the context of GIS. I will try to introduce these names very, very shortly. But let's go ahead and look at two names that we always, or two English words that we always use them, and we use them kind of equal, but they are not equal. So here are the two different English words: data and information. Data and information. Because remember, our system is called geographic information, not geographic data system, geographic information system. So the question is data and information, we mean the same thing? I know that in our life, we simply exchange them. Huh? We sometimes say, I have data, I have information. Actually, they are not the same. Data and information, they are not the same. And I will try to explain within the next two slides the difference between data and information. Now, data is simply some numbers that we collect. For example, let's watch this example here. Let's say in one area in Canada, I am interested to see those people, they speak English, and those people, they speak French. So you can see here on this table on my screen, there are how many columns? 1, 2, 3, 4, 5 columns. And also we have 4 different rows. And so for those 4 different rows, we are able to find what is the area in a square kilometer, how many people they speak English, and how many they speak French, and what is the total population. The way you see it right now, this is simply data. We have collected those, and we have never put any effort to simply organize them, or maybe to come up with a better, details of them, I would say. Now watch this. Once I go to the next slide, you will start to see how do we turn our data into information. So what I did, I created here a simple chart or bar chart, simple bar chart. And what this bar chart represents, it simply reflects the data in the same table. So those are equal. So those are in numerical format, while those in a graphical format, where for every area, and remember how many area do we have? We have total of 4 areas, area number 1 through number 4. In every area, we simply have the number of English speakers and French speakers. And we can represent them in a graphical way that allows us to have a better view of our data. So we kind of put some efforts to turn our raw, dull numbers into graphical format. I'm asking you which one is easier to extract that area number 2 has the highest number of English speaker. Which one? The table or the graphical format?
The table.
So in the table, you think this table is easier to know?
No, the graphic.
The graphics you can see, look at this blue bar here. So the blue bar here you can see is the tallest. It means I can tell that area number 2 has the highest English speaker. Which area that has the highest French speakers? And remember, look at the legend here. So it looks like area number 4 has the highest number of French speakers. Now you can see we have to put some effort. We turn our table into a graphical representation. So we're trying right now to tell you we have trying to turn our data into information. Now, what can I do with the information? So look at this, and I look. The thing is that the process will become more even difficult if you think that in this table here I have 1,000 records. Remember, here I have 1 area, 2 and 3 and 4. Okay. How about if I have 1,000? I'm asking you, which one is easier to get information from the table or from this chart? I'm talking about 1,000 areas. Okay. Obviously, the chart work is even better because you can find your question very, very easily. Now, there is one question to this. What can I do with the chart here? For example, let's say I'm planning to build a French immersion school, a school that teaches all the subject in French. What do you think? Where should I build my school? Should I build my school in area number 2, where it has minimum number of French speakers? Or should I build it in area number 4? Or maybe I can pick the location somewhere in between area 1 and area 4, where, maybe this school will serve area 1, area 4. These kind of questions, it will lead you to an informative decision. While if you just take and build your school into area number 2, looks like there's no much probably interest in area number 2. While if I'm building it in area number 4, that's a good informative decision. And even I can move it somewhere in between area 3 and area 4. And probably if there is one location that is common between area 1, area 3, area 4, then I can build it this location. So you can see here, I'm trying to get the best decision out of my available data. You know what? Here is an example outside this slide here. You guys wrote your midterm exam the other day. Okay. And you know what? Maybe next weekend or maybe over the long weekend, I'm going to spend some time to mark it for you. And then when I mark it, what do I get? I'll get something like that. Okay. I'll get something like that. I will get here, you know, Tahir Hassan failed, got 0. And then let's say Matthew, he got 100. So I have here bunch of numbers, okay, bunch of numbers. And what are those numbers? Those are my raw data coming from marking the test. Now, how many total numbers do I get? Let's assume that we have in our class here, we have 30 students. So it looks like I'm going to get 30 numbers. You know what? The way that my marks is simply a data, it's not information. It doesn't tell me much, okay? Because you can look at individual student, you can pick the mark for midterm exam, but you cannot get an impression on the class, whether it's better than my municipal section or even weaker. So really, this is called the data. I'm asking you, what if I spend some time on the weekend and then using Excel, I'm able to estimate the average and the standard deviation and the maximum and the mean and get some statistics, which means from my 30 numbers, I'm going to summarize them in 3 numbers, huh? Like what is the maximum, what is the average, and what is the standard deviation. What did I do? What I did, I simply turned my data into information because I kind of summarized them, organized them in a way that just by looking at 3 numbers, I can judge whether this class needs extra help. Maybe I can offer you more time one-on-one. I'm hoping that this discussion gives you the chance to understand the difference between data, which is raw, unprocessed, completely useless, while when you put some effort and put it to organize it, then you can turn your data into information. And let me ask you one question before I proceed. In 2021, do we have problem with the data, like we don't have much data, or we have so much data, but the problem is how can we extract information from the available data? Anybody have any thoughts? I'm gonna say my question one more time. In 2021, the data is scarce, like we don't have much data, or we have so much data, but the problem is we want to organize them and get the best information out of the available data. Any thoughts?
We have a lot of data.
Yes, sir, that's 100% correct. You know what? In terms of data, we have a lot of data available for us, but the question is, we need a system, and the system is able to allow us to ask questions and get the best out of our data in terms of information. Okay? Now, to be honest, and that's exactly what's happening here in GIS, we're trying to make a special query, ask about one phenomena. Where does it happen? How does it happen? And allowing the system to give us a smart answer for that. Okay? Now, I think we talked about this one. We talked about the data is raw, form, almost useless, while the information is compiled in a way that we can interpret them. And again, how we do that? By turning our numbers into graphical format, into colored maps. And so it allows us to visually see our data in a better way, and we can take informative decision. Now here is this slide is one of the most important slides in our course. Very important. It looks like very simple, but you will see this discussion. It will really make you understand what is the relationship between surveying and GIS. Very important. So please pay attention. Okay. So in our GIS system, we simply deal with 2 types of data. Watch this, huh? No more, not 3, huh? Only 2 types of data. One of the data is called spatial data, okay? And what does it mean? It means the location of one phenomena. Is this phenomenon happening in Calgary or happening in Edmonton or maybe in Vancouver? And so that's simply the geographic part of our data. It's simply spatial data where my phenomena is happening. And again, if you question what does mean phenomena, just wait for a second, huh? Because phenomena is number 2, which is something called attribute. data. So now, for example, the attributes is simply the phenomena that we're talking about, we're trying to describe. And it can be one of so many examples. For example, the phenomena or the attribute could be road condition, could be the type of the pavement, could be the design speed, could be the traffic density, and so on and so forth. So let me give you an example here. I'll try to make an example on Calgary major roads, okay? And for example, here we have something called Deerfoot. You guys, if you live in Calgary for maybe for a couple of years, you'll know what do I say, huh? So we have here Deerfoot. And let's say here we have 16th Avenue. And we have the Ring Road. And, you know, we have Glenmore, okay? So those kind of main roads. And I'm assuming, you know, my freehand writing, okay, or freehand sketching, this is a map of Calgary. So right now, this map is only the first type of data. It tells you where are those, you know, elements, like where is my Deerfoot and where is my Stony Trail or Ring Road. It gives you all the spatial data, where they are in terms of coordinates, in terms of radius, of curvature, the XYZ. And this simply is your first kind of data. Here we go. So this is your spatial data. Now, if we go and say, okay, you know what? Let's ask, okay, on 16th Avenue, what is the speed on 16th Avenue? You guys probably know, huh? In most segment of 16th Avenue, it is 60 kilometer per hour, 60 kilometer per hour, okay? So I'm asking you, is 60 kilometer per hour has to do anything with the geometry or the location like XYZ or anything like that? This is the 60 kilometer per hour, which is the design speed. It is simply an attribute. It's a property of my 16th Avenue. Same, you can find the same attribute in other roads. For example, Deerfoot in most sections, it's 100 kilometer per hour. Maybe Glenmore is 80 kilometer per hour. Those numbers are the design speed, and it's one of the attributes. And what is the attribute? It is the second kind of data that we're dealing with in GIS. Okay, is that all it like it's only the design speed? No. If we do some collecting some data, if we, for example, drive on all the roads, like for example Deerfoot, we could, for example, count the traffic density. Traffic density, it means how many cars they flow in 1 hour. Okay, and this number here, is it spatial data or attribute? Any help? When I talk about the traffic density on Deerfoot, is that has to do with coordinates or location or geometry, or it has to do with attributes or
An
properties
attribute.
of this line?
It's an attribute.
It's an attribute, sir. Thank you so much. And you can expand the discussion by talking about pavement type. Is it asphalt or concrete? You can talk about pollution, for example. What is the carbon monoxide emission on all those roads, on every single road? Really, as I said, this discussion is very important because now probably you start to know what is the relationship between GIS and surveying. I'm asking you, who can provide us with the spatial data, which is about location? How can we get our spatial data for any GIS project? Should we call, for example, a structure engineer? Should we call, you know, soil tester? Like, who do we call to get our spatial data?
Surveyor.
Surveyors. Okay, so let's see. Here is the point, huh? So GIS system in general, in a nutshell, it's a combination, huh? We're combining attributes on to where they exist on the earth. When we say where, it means we're talking about location, and location is always provided by a map. Where do we get our maps? We get it from surveying, and that is really the deep connection between GIS and surveying. Bottom line is every GIS system, whether you use it in with the city of Calgary, whether you use it for any application, simply it requires you at the first step is to acquire your spatial data, which is location data, which is simply a base map. Look at the name, please. This name is very important, huh? Base map. It's a map that you start with and simply attach your attributes to your geometries on this map. So I'm going to start with the Calgary road map, and I'm going to build up from this map. I will build up my GIS system where I will come and look at for one attribute, like for example, design speed, and I'll attach the design speed to every individual element on my map. So for example, what is the design speed for 16th Avenue or Glenmore or Deerfoot Trail and so on and so forth. So in GIS, conclusion is in GIS, we deal with two different kind of data. One of them they call spatial data, where it's about location, in addition to another thing, a different kind of data called attributes or properties. Remember this. No matter what is the field of the application, doesn't matter whether I'm creating an GIS system for forestry or for city assets or any application. Here is the point. It will always be combined of spatial data. It's your base map in addition to the attribute. The attribute will vary. The attribute will vary. What does it mean? It means if I'm building a GIS system for city road maintenance, a system that tells the city to this year you have to pave Crowchild, and the next year you have to pave, let's say, another road, then the attribute will vary. But what will not vary is we always need a base map. Hopefully now you start to understand the relationship between your GIS and surveying. Why is that? Because every GIS system requires a base map, and base map comes from surveying. Now, in GIS, and this is something you will see in my class, you can see here, this is diagram here, it tells you a GIS platform. So in our class here, we will be using a software called ArcGIS. ArcGIS. It's a platform that uses all the idea of GIS. And when you look at this diagram here, you see GIS is in the core, in the middle. And simply the GIS integrates several concepts, okay? One concept probably you know, what does it mean? CAD. I know that you guys learned CAD in the last year, huh? So you know CAD, and also you learn CAD with me a little bit in Civil 3D. So CAD is computer aided design, okay? When we draw lines and curves and, you know, we have some add, some hatch and stuff like that. So this falls under CAD. You also, in my class early on, you learn a little bit about cartography. And cartography is the art of creating maps by including the surveys in addition to things like scale and north arrow and legend, stuff like that. So this falls under cartography. Also, we touch a little bit, not really much on remote sensing, where you take an image of the earth and you can simply detect one phenomena, for example, like fire, like forest fire, or maybe like oil spill. So this is called remote sensing. Look at the name, huh? Remote sensing. So we're trying to get some sense of information while we are completely away, and that's what makes it remote, huh? And then finally, we will simply talk about database management, okay? Database management. I'm not sure how much you know about database, but in simple terms, database is simply like Excel. Huh? So in Excel, we simply collect some numbers and we organize them in database. So ArcGIS simply integrates all those fields, CAD plus cartography plus remote sensing plus database management, all of them integrated in one platform. Now, based on the discussion we had before, you know that GIS, it combines a spatial data plus non-spatial data, which is attributes. Let me ask you, what do you think could be the field of the application? I'm trying to build a system that I will simply place a query to ask the system about where one phenomena is happening or where one phenomena is happening very strongly. How can I apply this, or which field of the application? Is it limited to only surveyors, or everyone can use GIS? So the answer is very simple, and you will know this as we go. The answer is everyone on this earth can use a GIS in different application and different domain, including surveyors. That's not new, huh? Looks like kind of very natural, huh? Surveyors, engineers, environmental scientists, geographers, forestry, dispatchers, criminology, government, uh, health sectors, you know, pandemic, stuff like that, especially we are in the pandemic, huh? Dispatchers. You know what? I have an example for you, and probably this is a good time to look at this example. Very nice. I watch this. So I just went to Google and I said, crime map Calgary. And you can see here, we're talking about crimes, huh? Crimes. And we're saying map. So we have our spatial data. It's a map, and it's talking about crimes. So you know who's using this? Use this map here. It is built by Calgary RCMB. And when I did the search, I got this website. So please watch me. So this website here, it is coming from Calgary RCMB. And it just show you community crime map. So right now the map is loading, and just be patient. The map is loading, and watch this. This is a map for Calgary, if you agree, huh? If you agree, this is Calgary map. And you can even locate where you live in Calgary on this map. Now, what you can do is look at the right side, and the right side gives you a control of this, what this map will show. So let's drop this menu. So this first menu, it says group category. If you drop this menu here, I'm gonna choose disorder, I guess. I'm sorry, a crime. And I'm gonna click on crime and remove disorder. I'm gonna see only the crimes, and I will say apply. And the next part is crime can be so many things, huh? There is a like let's say there is a family violence, there is break-in, there is car theft. There are so many kind of crimes, and those are simply our attributes. So if I drop this menu here, you can see here are the crimes that this map will show. Will show, for example, theft from a vehicle, theft of a vehicle, residential break-in, and so on. For example, let's look at theft of a vehicle. Theft of a vehicle, I'm going to apply. And by the way, you can choose as many as you wish. For this example here, I will just choose only one attribute, which is theft of a vehicle. Apply. Now, next one is the year. So if you drop this menu, looks like we have data starting from 20, not sure where they start, but probably back in 2012. I think that's the earliest, huh? And we have 2013 and 14 and 15. Let's look at the latest, huh? The latest here is a 2019. I'm not sure why the city stopped, probably because of the pandemic, but I chose here 2019, and I say apply. Now look at this. Now what happens after I chose my theft of a vehicle and then 2019? You can see here this website is showing me a map, and this map is for entire Calgary, and kind of goes by residential neighborhood. And you can see every residential area, it has one color, huh? It was one color. If you are curious what are those colors, you can look at the legend. Okay, for example, here I have 100 like this dark color. Okay, and then against this very yellowish color on the bottom here. Those number, what do they mean? It means if you see your neighborhood colored with the red, dark red, it means like bloody red. It means we have 148 theft of a vehicle. And the yellow one is between 123. So I live in the Southwest in a community around this area. I'm not going to tell you exactly where I live, but look at my area where I live, which is south of Glenmore Park. Okay. Now look at the color. It means my car theft in my neighborhood is very, very minimum as compared to the city. Okay. So 1 to 23. Now, on the other side, if you go to one area in Calgary, which is Beltline, so we have here the highest number of car theft. We have 148 incidents happening in 2019. Now, some of you I know will ask me, okay, now, few questions. Number one, who can simply use this map right now? Any help? Anybody? Anyone can thought that someone is interested to know what is the car theft rate for every community? No clue? How about if I tell you about insurance companies? Insurance companies. Hello? I'm asking you, you think insurance company would be interested to look at this map?
Yes.
Because when you simply insure your car, you're gonna tell them your address where your car every night sleeps, right? And if you tell them I'm in this, here is my postal code, here is my community I live in postal code T2W, it will simply tell you, you know what, the car theft here is very little, and probably your car will be safe. I'm gonna give you a minimum rate. While if you live somewhere, let's say somewhere in the city, let's say in Beltline. So, for example, they will increase your premium for the car insurance. Okay, so is that good for insurance company? Of course it is. And again, it goes on and on. For example, if I change my car theft into, let's say, break-in, okay, I'm asking you, if you have little kids, okay, or even if you don't have little kids, let's say you wanna buy a house, which area you want to buy a house? Would you go to an area where it has lots of break-ins?
No.
Okay, so again, here is, I'm trying to get you very slowly into what is the importance of our data, how can we turn our data into information, and how can we take a best informative decision from our maps. Hopefully you start getting the idea of GIS. Now, as we said, everyone in our world can simply use GIS. Now, the question is for you, did I use GIS before? Like, ask yourself, did I use GIS before without me knowing anything about GIS? The answer is yes, you've done this. And I will prove it for you, hopefully before the break, okay? So I'm gonna quickly. I'm not really big fan of history, or I'm not a history teacher. But always, it's nice to know what is the development, how the things developed in GIS from where it started until now. I know some of you think, Tahir, just show us, a GIS map on a website, and internet is very recent. Okay, is the GIS was developed only when there was internet? Only? No, the GIS is very, very old. Here is the point, huh? The point is map, they are available for users for very long time, maybe a few hundred years, okay? As soon as you start attaching an attribute to one map, then you are doing GIS in a way. So I'm going to tell you the start. The start goes back to, or the history goes back to early 19th century, where it was the first time they start to create geological map of Paris. So it's a map, but we say, okay, you know what? This area, it has a like this kind of geological formation. This area is rock, this area is sand, or this area is this kind of soil. So you can see we're starting to attach an attribute to a map, and this what will turn your map into GIS map. Again, there is some examples here, but really one example, it's in mid of 19th century. I myself watched a documentary on Netflix about this incident here. So mid of 19th century, London was overpopulated. They already have a sanitary system, like underground sewage system. But because of the increase of population, simply there was a problem. It was over flooding, and simply it was contaminating the water supply. And that time they get the water by simply digging a well and getting water from underground water. Okay. So what happens here is that people become sick. You know, they are very have fever, and nobody knows why. Nobody knows why. People are getting to the hospital and they are very sick. And using a very simple technique, they are able to identify the problem and they are able to fix the problem. I'll show you how. So what happens here, every time that a patient comes to the hospital sick, they will ask him one question: where do you live? Where do you live? And then once they have a map and they can mark, let's say this is a map of London, and it's okay, you know what? I'm getting this many patients from this area, and I'm getting this many patients from this area, but the entire London is okay, no problem. I'm getting problem here and there, and you can see when I say here, it means location, it means a map. So we just mark on the map where my patient lives. And guess what? Looks like the problem is there only. It doesn't exist all over London, but it existed only very specific locations. So they went to this location. They take some samples from the water wells, and they found that the water it's contaminated by the sewer system. And simply they shut down all those wells and they start treating people from cholera. And from this point on, what they did is they simply built a new sanitary system for London, almost mid 19th century. You can see this is a good example of knowing where is my phenomena. It tells me how to solve it. You know what? There is also some development here. I'm not going to go through it, but the thing is, really, the GIS, although it started in early 19th century, however, in the mid of the 20th century, where the computers have been invented around 1950, 55, there is lots of development. Everything with the development of computers, everything has changed. Okay, so now we can apply the concept of GIS not on a paper map, but also we can do it using computer. You guys know that computer, when they started, they were super huge. Maybe it was the size of a room, very expensive. Can only big companies can buy them. But with the time, I'm asking you, what is the case in 2021? Our computers are getting very efficient, are getting very small, very affordable, allowing everyone to use GIS on a very compact platform. For example, you see on my screen here 3 examples. This one is a tablet, this one is a cell phone, and this one is not really tablet or cell phone. It's a small handheld GPS GIS platform. Okay, so this one probably you or maybe your younger brothers or sisters, maybe you have a tablet. Everyone has a cell phone, and this one is kind of very specialized. Probably only a surveying company will own one of these that has a GPS and GIS platform. Okay. Right now, GIS becomes so popular, it's very affordable, and everyone is almost using GIS. You know what? Here is an example of that you guys yourself, you yourself used GIS without even knowing that you are using GIS. Google Map is an example of GIS. And I know some of you will say, no, 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 wait, 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 wait. Google Map is not GIS. Google Map is GPS. I think that is maybe some of you will think this way because you have Google Map on your cell phone. If you're going to a friend or going to pick one of something that you buy of Kijiji or maybe Facebook and you want to go pick it, you will ask about the address. You plug in the address on your cell phone. It will tell you, turn left, turn right, in a few 100 meters, take the ramp. So some of you think that Google Map is GPS, while the surprise is really Google Map is a GIS system, not a GPS. Yes, you can use it to aid you to go to your destination, but primarily it is a GIS system, and I'll show you how this is happening. Because simply the idea is you can simply do your use Google Map on your computer, which has no GPS, and it tells you you will need to go along Glenmore, and then turn north on Crowchild. You can drive for 3 kilometers and so on and so forth. It gives you all the direction, and you can do that completely offline. You can simply have no GPS, and you can still get some direction. So that's why Google Map is a GIS platform, and I'll show you how. So I just want to quickly remind you, and probably you've used this 100 times, but I just want to remind you of how to use ArcMap. So we simply here place two things. We place where we are, and if I have GPS, that's great because simply it can detect where we are. However, GPS doesn't know where are we going, So we simply have to input our destination, which can take several form. We can add an address, a street address. We can add a postal code. We can even add fee and lambda, like geographic coordinates, okay? So all these options are available. Once we add our location and destination, simply we have to choose the means of transportation. So we can see Google itself, it has, for example, driving a car, taking the public transit, walking, and even here biking. And in the new version of Google Map, it will give you even the Uber fare, or if you're picking 2 points where there is no road in between. For example, let's say I pick Calgary and then the next destination is Cairo. Can I go to Cairo by car or even walking? Can I? Anyone knows where is Cairo in Egypt? It's somewhere in Africa, North Africa. So there is no way for you. I guess there is a way. By the way, I guess that's what I'm thinking. I guess there is a way. Otherwise, we couldn't see First Nation here, right? So because simply you can cross from Asia to North America through the North Pole. But again, that's very cold. Okay, so let's say I want to go to. It will take forever if I go by walking. So if you want to fly to Egypt, also I think Google Map right now, it gives you the fare, like the ticket, how much is going to cost you to fly from Calgary to Cairo. Okay. Anyway, we have so many means of transportation. Let's say we take the sea train. Okay, good example. Let's say sea train, like the public transit. So what happens here? Google Map will simply give you the plan. Will tell you, you know what? You will walk from your house, 200 meter. You wait on this bus number. You wait for bus number, let's say 14. It will come on 11:55. It will take a 16 station. You will need to change on Southland station to sea train and so on. It gives you all those steps. Now let me ask you, how the system will do that? Looks like the system is connected to some database that it knows, for example, that bus number 14, it goes along these routes. It will come this often on this station. So the system is connected to database from the city of Calgary, and this system is online system. It simply updates itself. Anyone used Google Map and sometime it tells you the bus will be late by 2 minutes or be late by 5 minutes? I guess some of you did. So again, and if you're not using the public transit even, right now you can use, for example, use your own car. If you use your own car, for sure, it will tell you direction, like drive on these roads. It will even give you ETA. And what is ETA? Anybody knows what is ETA? ETA.
Estimated time arrival.
Exactly, there. Thank you so much. I give you ETA. So if you think about it, okay, how can this platform gives you ETA? It's as simple as if you are driving right now, that's one story, and if you're driving tomorrow morning, that's a different story. If you're driving tomorrow morning, it means we have no data in the future, so we just simply use the design speed. Let's say Crowchild is 80 kilometer, and you guys know if I know the speed and I have a map that gives me length, I can know the time. So it simply tells you you need 19 minutes to arrive to your destination. If you're driving right now, it's a different story because Google Map, they are connected to some database that knows the exact speed right now. The city of Calgary has a Bluetooth system that they can track the speed, not design speed, the actual speed on the road. In addition to every one of us, you have a GPS. And the GPS, I can tell you, Google tracks our motion. That's not a secret right now. They track our motion and they know the speed, not the design speed, the actual speed on the road, so they can tell you a very good estimate of your ETA. I've used it 100 times. It gives me really an accurate time of arrival. If I'm buying something or meeting a friend, I can tell them I can be there in 15 minutes. Even if you have one accident, there is one way to report accident and even radar on the road by clicking one button on Google Map. I'm not sure if anyone have used it, but you can, when you're driving with your car, you can report accident, or you can even report a radar speed, okay, like speed traps. And simply the Google Map will give you a warning, before you hit the speed track, or if there is accident and means there is road closure, it will give you kind of reroute you around this area. So you have used GIS before without you even know about GIS. And I think this is good time to break. Time now is 10:53. So I will give you 10 minutes a break if no question, and we'll come back after 10 minutes. Let's see if anyone has any question. Go ahead, please, if you have any question. Very quiet, which is, I'm not sure if this is good news or bad news. Hopefully you're liking what I'm saying, and we'll see you guys in 10 minutes. So we'll come back here at 11:04. Thank you so much.